Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. Now, in this particular paper of P3, which is of October-November 2024, variant 31, let's get started. It's a walkthrough solution. So now let's look at question number 1. It says the polynomial where a and b are constants is denoted by px. It is given that 2x plus 1 is a factor of px. That means if I equate 2x plus 1 equals to 0, I get the plug-in value of negative half. Therefore, p of negative half is 0. So this is an application of factor theorem. So this one, my bad, it's over here. This one is about factor theorem. And then the second part, it says, when px is divided by x minus 4, the remainder is equal to 3 times the remainder when px is divided by x minus 2. So now the second equation is about factor remainder theorem. So the first one is this thing, which is factor theorem. And the second one is remainder theorem. So when we plug in a value, and the remainder is not 0, it is something else. That is the application of remainder theorem. So division by x minus 4, plug-in value is 4. Division by x minus 2, plug-in value is 2. Also over here, division by 2x plus 1, plug-in value is negative half. Take care of that. So p of 4 is 3 times p of 2. This is p of 4. And this is p of 2. And this is the factor of 3, and that is how we get this second equation. So that is the first equation simplified. This is the second equation. We solve it simultaneously. We get the value of b as 11. We get the value of a as negative 32, and that is the final answer, such and such. So the first question is done. Let's move to second question. So second question is about integration. And specifically, it's about integration by parts. So this is by parts integration. And over here, the first part, this is about polynomials. It's part of algebra. So now let's get started. It says find the exact value of this integral. Give your answer in this form: a ln b plus c, where a and c are rational and b is an integer. So when it uses the word rational, that means it can be expressed as a fraction of two integers. So that is a rational number. This is an integer. And so is n. So that's a rational number. Now it says we have to integrate it. Now, the very first thing, x square ln 3x. When we talk about integration by parts, the first thing is the rule for choosing u. So which one should be u? So u stands for, this thing, L stands for natural log, A stands for algebra, T stands for trig, E stands for exponential. We know that it has to be a product of two functions. So over here, it's algebra and ln. Algebra and ln, so u should be taken as ln. Whatever we take as u, we differentiate. Whatever we take as dv, we integrate. And remember the formula, that is u dv, that is uv minus integral v du. And that is exactly what is done over here. U v minus integral v du. So this is u, this is v, that's right over here. Minus integral, multiply these two and simplify. So this is x cubed over x, that is x squared over 3. That is basic integration. The power increases by 1. So this becomes x cubed, 3 before and 3 after. The product is 9. And the next thing that I did was to take something common. What have I taken common? I first took x cubed common. And then 1/3 and 1/9, I took 1/9 common. So these are the two things that I've done. And then when we plug in the limit, So naturally, the limits will be plugged in this thing also, this as well as this. So make sure you draw proper brackets. And then the limits are there. So now, first of all, the upper limit is 3. So 3 into 3x, that is 9. And the lower limit is 1, that is 3 into 1 is 3. And the rest of the thing, you can have a good look at it. So this is 3 cube over 9, 27 over 9, that is 3. 9 can be written as 3 square. So let me write over here, 9 is written as 3 square. And over here, this 3 was written as 3. And this thing was basic division. That is 1 over 9. That's 1 over 9. I open up the bracket with a negative sign. This becomes negative. This becomes positive. Take care of this. This is positive. This is negative. Now, this is the ln term. This is the ln term. Write these two together. 3 into 3 is 9. This 2 comes down. So this 2 over here is this 2. That is the eraser. So that is this 2 over here. And this 3 into 3 becomes this 9 over here. And then this is 3 over 9. This 3 over 9 becomes 1 over 3. So now I have taken ln3 common, ln3 common, that is 18 minus 1/3, 17 2/3. So that is ln3 over here. And this is simplified, and this thing is done negative 3 plus 1 over 9, negative 26 over 9. And that is the answer in the exact form. Now, what have they written? A ln b plus c. So let me write underneath it A ln b plus c. And they are saying that b is an integer, correct? A and c are rational. So this is rational, this is rational, this is all good, all clear. So A is 53 over 3, C is negative 26 over 9, B is 3. These two are rational numbers because they are a fraction of two integers. That is what rational is. And 3 is an integer. So make sure you convey every necessary detail to the examiner. Now, question 2 is done. Let's move to question number 3. Now, this thing, it looks like this is about implicit, differentiation of implicit. So sometimes they give implicit, sometimes they give what you call parametric. Let me just double check. Yes, the recording is all good, all clear. So now over here, find the gradient of the curve at the point 1, 0. So now the rule of implicit differentiation is whenever, wherever you differentiate y, so dy by dx will appear. Derivative of x is 1, derivative of y is 1 into dy by dx. Make a habit of writing this one also. So that is also part of this. And then over here, 3x square y, this is u, this is v prime. This is v, this is u prime. So this is u, this is v prime, this is v, this is u prime. So whenever we differentiate anything in terms of y, dy by dx will come. Anything in terms of y, dy by dx will come. And the rule for differentiation of log, we know that log ax plus b, actually ln, log to the base e, that's the only thing that we focus on. So log, I'm writing log again, that is ln ax plus b. If I differentiate it, what happens? The thing inside the bracket goes down and the derivative of the bracket goes up. And then what we do is that plug in these two values. So we plug in these two values, which is x is 1, y is 0. I did not make dy by dx the subject. I comfortably plugged in the value of x and y, and then I made dy by dx the subject. So that's a very nice answer, which is half. So got the idea for 4 marks. So 3 questions are down. So now over here, question number 4. It says, show that sec power 4 theta minus tan power 4 theta is 1 plus tan square theta. We want everything in terms of tangent. Now remember the rule, a square minus b square, that is a plus b, a minus b, very, very useful thing. Similarly, a power 4 minus b power 4, that is a square plus b square, a square minus b square. So therefore, sec power 4 theta, it's already written over there, so no need of writing it again. Sec power 4 theta minus tan power 4 theta, s4 minus t4, that is s square plus t square, s square minus t square. Now, this is the only identity that I have. If I transfer this to the other side, what do I get? Sec square minus tan square is 1. So this is replaced by 1. Sec square plus tan square. Now replace sec square with 1 plus tan square. Sec square is 1 plus tan square. So basically, you're using this identity twice. And then you simplify, and very easily you get this answer for 3 marks. Sometimes the working is less, the thinking is more. Now the next part. Now it's a big trig equation. And this time, what have they changed? So they have changed this thing, which is instead of that x over there, instead of theta over there, they have written 2 alpha. So sec power 4 2 alpha minus tan power 4 2 alpha is 2 tan square 2 alpha, sec square 2 alpha. Now this thing on the left hand side, link it with part A. This is related with part A. So we have already proven that this thing of this sort will be broken down into 1 plus 2 tan square. Instead of theta, what do we have? 2 alpha. So a note for yourself, theta is now replaced by 2 alpha. Got it? And then this thing on the right hand side, that is just the usual stuff. That is 2 tan square 2 alpha, sec square 2 alpha. And then the same thing over here. And then I wrote everything in terms of tan, because on the left-hand side, again, everything is in terms of tangent. So now when you have this, you work with a disguised quadratic equation. So this is disguised quadratic equation. And over here, tan square 2 alpha, tan square 2 alpha, tan square 2 alpha. So I'm writing this thing as m. And then this equation, there were no m terms because the m cancels out. So the good thing is m square is half. Therefore, m is plus minus 1 over root 2. But m is tan square 2 alpha. So tan square 2 alpha is plus minus 1 over root 2. We again take the square root of that. So that is plus minus 1 over 2 raised to power of 1/4. So basically something raised to power of half, raised to power of half, that is raised to power of 1/4. That is what has happened over here. Your indices should be very, very strong. Now the answer will be in all 4 quadrants. And alpha over here lies between 0 and 180. So therefore 2 alpha lies between 0 and 360. And over here, I'm using the symbol for the basic angle as beta. Beta is the basic angle, the acute angle with the x-axis. So we always calculate with the positive ratio. We work in 2 decimal places. And beta is the basic angle that's written over here. Therefore, tangent beta is this. Therefore, beta is this much. So 2 alpha is 40.06, first quadrant, second quadrant 180 minus basic angle, third quadrant 180 plus basic angle, fourth quadrant 360 minus basic angle, and then make alpha the subject. All final answers should lie between 0 and 180. 0 and final answer between 0 and 180, 2 alpha was lying between 0 and 360. So that is how this particular question is done. I think we started at 12:04. So let me just go up and let me focus on the first 6 questions. How much time is it taking? So remember the 3-step procedure that I focus on: the first step, the second step, and the third step. So now over here in the first one, I'm focusing on questions 1 to 6. And I started at 12:04 p.m. Let's see when it stops. And then let me focus on questions 7, 8, and 9. And then questions, usually it's 10 and 11. Maybe there is a 12 one, but usually that's the way. So now let's see how much of the time is there. So we have reached up till question 4. Now let me start with 5. Question number 5, it says, by sketching a suitable pair of graphs, that means you have to draw 2 graphs, show that the equation. So one equation is the ln1. Let me mark it with green color. This is ln1 plus x. That is the one I need to draw. And the other one is the blue one. That is 2 plus e raised to power of negative 0.2x. So now we know that e raised to power of negative x goes like this. Because of this 0.2, steepness will change, nothing else. The y-intercept is 1. But when we add 2, the y-intercept increases to 2. Originally, the asymptote was y is equals to 0. It increases by 2. So that's how the blue graph is drawn. The blue graph is this one. And ln1 plus x, that is the working domain. Whatever is over here, make it greater than 0. X is greater than negative 1. So that is the asymptote I have drawn. The graph lies to the right of the asymptote. X-intercept, whatever is over here, make it equal to 1. Therefore, x is equals to 0. Some people, they can also do it by transformation. This is y is equals to ln x. When it's x plus 1, it is shifted 1 unit to the left. So instead of 1, the x-intercept is now 0. And instead of the vertical asymptote at x is equals to 0, this becomes x is equals to negative 1. That is another approach. At how many points are they intersecting? They are intersecting at 1 point. So therefore, there is one solution of this equation. So 1 point of intersection means one solution or one root of that particular equation. So that thing is done. Now the next part, show by calculation that this root lies between 7 and 9. So let the root be alpha. So sometimes they write it like this, root lies between 7 and 9. So what is the first thing that needs to be done? That is transfer all terms on left-hand side and right-hand side should equal to 0. When you transfer all the terms, you call it fx. And then you plug in one value, you plug in the other value. This is coming out to be positive. This is coming out to be negative. Since, let me write over here, there is a change of sign between f7 and f9. Therefore, the root alpha lies between 7 and 9. This is called change of sign method. So this is done by calculation, change of sign method. This is done by calculation, and this is by graphing if possible. So now the next part, it says use the iterative formula. Use the iterative formula to determine the root correct to 2 dp, give the result of each iteration to 4 dp. That's a standard rule. And exp, x is an alternative notation for e power x. That's for convenience. Now, this question was about iteration. Numerical solution, that's the name of the whole chapter. So which topics have they asked till now? They have asked about trigonometry. And this is ID plus equation. This is ID, this is equation, nothing is asked. They asked about implicit differentiation. They asked about integration by parts. They asked about polynomial. So polynomial, integration by parts, and then this thing, implicit differentiation, trigonometry, numerical solution. So now let's focus on this one. It says we have to determine this root, give result of each iteration to 4. So now the plug-in value, I chose this plug-in value to be 8. Why did I choose it to be 8? Because that is the safest option. Alpha lies between 7 and 9. So the mid value is the best option that you can choose from. So now the next thing, I'll plug in it over here. That is 8 into 0.2, that becomes 0.6. Use a calculator, simplify, and work it out. That is the first working. The second working is this thing. Now we are getting 8.0421. This is 8.0269. The answers are very, very close. but out after rounding off to 2dp, they are not the same. So continue one more step. This after rounding off is the same. So therefore, we would stop our working over here. So we would stop this thing. And because these two answers are exactly the same, 8.02, 8.03, 8.03, this is the same. So therefore, we would stop over here. These two are exactly same. Therefore, the root of the equation, the solution of this equation is 8.03. Now let's look at question number 6. This looks like differentiation, the first part. This looks like integration, the next part. So now one question of differentiation was asked earlier. One question of integration was asked earlier. Now it's a combination of differentiation and integration. In differentiation, it's about maxima, minima. In integration, it's about area under the curve. Now, first of all, look at the graph. There is a turning point over here. It's finishing off at 3/4 pi. I mean, it would be a continuous graph, but that is where they're stopping. The diagram shows the curve for x between this much and this much, and its minimum point m. That means we should know that the answer would lie between this particular value, this particular value. This particular value would be the x-intercept, y is equals to 0. So I'll be getting one of this value, one of this value. Shaded region is bounded by the curve that lies above x-axis, and the x-axis itself is denoted by this thing. So this is above x-axis all the way till the x-axis, that is r. Given that the x-coordinate of m lies in this interval, find the exact coordinates. Exact coordinates means it has to be either in the fraction form, in terms of square roots, thing like that. In terms of exponential, in terms of ln, and we need both the x and the y coordinate. Now, first thing first, a lot of people, they make a mistake over here, and let me tell you what mistake do they make. So the mistake that they make is this thing. Let me just adjust this thing. That is, first differentiate, then if there is a need, then simplify. So as soon as you see 2x, do not get excited and think about double angle formula. First differentiate. So when I first differentiate, what do I have? This is u. This one is u. This is u prime. Hold for a second. This is u. This is v. This is v. This is u prime. U, v prime, v, u prime. There is a positive sign in the middle. Now let's double check the working. The derivative of sine is cosine. The 2 comes out and multiplies. And then what did I do? I took this 2 and this cosine 2x, 2 and cosine 2x. I took this whole thing common out. I'm left with this. dy by dx equals to 0. That means 2 cosine 2x is equals to 0. Cosine 2x is 0. That means 2 cycles in 360 degrees. Therefore, I just drew one cycle in 180. So 180 is pi. And we are looking for what? We are looking for equal to 0. That is this value and this value. This is pi by 4. This is 3 pi by 2. So this is pi by 4 and 3 pi by 2. So they both are out of the range. So both answers, let me mark it over here. This answer, that, and this answer. This is 3 pi by 2. And this one is pi by 2, 3/4 pi. My bad. That is 3 pi by 4. And this is pi by 4. They are outside of the range because 3 pi by 4 is right over here. But m is lesser than this. So that is why no solution. No solution because outside of range. So I think clarify it to the maximum. So this thing is done. And then over here, you can also write over here either, and this is or. Sine 2x is negative half. A basic angle, alpha is pi by 6. It could be in the third quadrant. It could be in the fourth quadrant. In the third quadrant, pi plus the basic angle. Fourth quadrant, 2 pi minus basic angle. These are two answers that you are getting. So this answer is within the range. that is 7 pi by 12. So this is within range. And you can, of course, use a calculator, and you can also work in degrees, if you have difficulty thinking about it. So accept x is equals to this. So now 2 times 7 pi by 12 is 7 pi by 6. Sine of 7 pi by 6 is negative half. Therefore, when I plug it in over here, that is this thing. Therefore, this comes out to be negative 1/4, and that is the exact coordinates. So the exact coordinates is in terms of fraction, it's in terms of pi. Next one. Find the exact area of region R. So now look at the working, which integration technique is being applied over here. Just double check. Now it says sine 2x, 1 plus sine 2x dx. First multiply, you get sine square 2x. So now sine square 2x, I think I wrote it somewhere over here. There it is. So sine square 2x is this thing. That is usage of double angle formula. So when we have over here x, sine square x, the double angle is 2x. When we have sine square 2x, the double angle is 4x. So this thing is replaced over here. So let me just do the replacement over here. So this thing sine square 2x, it's half minus half cosine 4x. And this sine 2x, the basic one, that remains as it is. So now let's look at the integration. This is the integral of this. And over here, integral of half is half x minus half as it is. This is sine 4x over 4. So now we have to plug in the upper limit. We have to plug in the lower limit. So let me just change this color so that we do not confuse these things. So now when we plug in the upper limit, that is pi by 2. So 2 times pi by 2 is pi. This is pi by 2 as it is. 4 times pi by 2 is 2 pi. And when we plug in the lower limit, that is over here, that is the lower limit 0, 0, 0. Now, don't be overconfident and always think that 0 means everything is 0. No, it's not like that. Sine of 0 is 0. This 0 is 0, but cos of 0 is 1. So therefore, this thing, remember this thing. So cos of 0 is 1. And there is a negative half over here. And there is a negative over here. So negative into negative, that becomes positive. So keep that in mind. You have to take care of this. Similarly, if I focus on the sine of 2 pi, that is 0. Half of pi by 2 is pi by 4. And cos of pi is negative 1 multiplying with negative half. So that is half, that is pi by 4. This becomes positive. Half plus half is 1. 1 plus pi by 4. That is again the answer in the exact form. So this is another question of exact thing. So question 6 questions are done. It is 12:33. Let me go to this first thing. So for 6 questions, 12 to 12:33. This is with explanation and everything. So this is approximately for walkthrough. This is 29 minutes. That means you can comfortably work in 45 minutes. So first 6 questions, 45 minutes. So now this is 12:33. Let me think of it as 12:34. And we are starting with the next one. So now this is 12:34 p.m. And let's see how much time would it take. So let me go all the way over here. And now we are starting with question 7, the second phase. So the second phase, that is the orange phase. That is the first one, that is partial fraction. And what's on the next page? It's partial fraction and binomial. This traditional question that strikes once in a while. So now the first thing, in partial fraction, the checklist, is it proper or improper? Highest power is 2, highest power after multiplication is 3, it's proper. Which case is this? So this is denominator with quadratic factor. Of course, a linear factor is also there, but the dominant factor is the quadratic. And second thing was that it is a proper algebraic fraction. So now the thing is this thing. We have a constant over the linear factor, bx plus c inside a bracket over the quadratic, cross multiply like this. That is taking the LCM, equate the numerator to the numerator. In quadratic, we always start with this. That is x is equals to negative half. We want to get rid of two constants at one time. So we are making this thing 0 by taking x is equals to negative half. This one will disappear. We will find the value of a. Now plug that value of a back in that equation. And now focus on this thing. Let x is equals to 0 so that this will disappear. And hence you find the value of c. So now c is plugged in and a was already plugged in before. Choose any other simple value. What could be simpler than 1? 0 is also simple, but that's used up. So now when we simplify, we get b is equals to 2. So b is equals to 2. And then c comes out to be 3. And then a comes out to be 1. So these are the three things. Now for the next part, if I focus on the next part, what things would happen? This would be 1 into 1 plus 2x raised to power of negative 1. That is for the binomial part. And this is 2x plus 3 multiplying with 2 plus x squared. That is for the next part. And then you have to do some adjustment. Why? Because the binomial that we do, that is of 1 plus b raised to power of n. The first term should be 1. The adjustment is already made. And what are they asking? They're asking this thing, hence find the coefficient of x cubed in this expansion. So first of all, 1 plus 2x raised to power of negative 1. This is the constant. This is x. This is x squared. This is x cubed. So we get all these 4 terms. All 4 terms are applicable for us. And now the next one. This is 2 plus x squared raised to power of negative 1. Take 2 common. This is 1 plus x squared raised over 2 raised to power of negative 1. This is applicable on this as well as this. So 2 raised to power of negative 1 is half. And then we just need one term, actually 2 terms from here. After the constant, 1 term. So now where were we? So we were solving this particular question. And we just need the first 2 terms. Why? Because the next term will have x squared over 2 raised to power of 2, which will become an x4 term. So we are not interested in that. So therefore, just 2 would be more than enough. And these are the 2 terms that we got. So now over here, coming back to the partial fraction. So this is the first one. That is this one. Over here, that is 1 plus 2x raised to power of negative 1. And we just need which terms from there. So we need the x term, the x cubed term. So since it's addition, we just need the x cubed term over here, not if anything else. And over here, 2 things are multiplying out. So this is 2x plus 3. Let me write this thing in blue. This is 2x plus 3. It is multiplying with 2 terms from the inside. That is the constant, that is x squared over 4. Because 2x into this, that will be of useless things for us. 3 into x squared over 4, but that's also useless. What about 2x into x squared? Yes, there is x cubed. So this is an x cubed term. This is an x cubed term. And what are we getting? So therefore, this is like this. We are interested in this. We are interested in this. That is giving us this thing over here. The purple term is already there. And then the overall thing is the coefficient of x cubed is negative 8.5 or negative 17 over 2. So that is the kind of working that's done. Question number 7 is done. Question number 8, a complex number. This was a little bit strange question, slightly strange. So in complex, there was algebra and there was this thing, basic trigonometry, or I can say loci. So these 2 things were there. Now it says, given that Z is A plus BI, I think I've done it on the next page because I've done it in two different ways. First of all, have a look at this. It says, given that Z is 1 plus YI, where Y is a real number, express 1 over Z in this form where A and B are functions of Y. So they are not just some constants, they are functions of Y. So Z is 1 plus yi, 1 over Z, 1 over 1 plus iy. And then what do? We multiply and divide by conjugate of denominator. And this is what you're getting. So break it up. You get the red part, which is 1 over 1 plus y square. You get the blue part, that is minus y over 1 plus y square. So A is this and B is this. So I've also written it over here. So B is this thing and A is this thing. Now, there are two different ways in which I worked out the second part. Let's have a look. So now over here, it says that A is this, and we have to prove this, show that A minus half whole square plus B square is 1/4. So one approach, let me focus on this. This is method number 1. So let me write over here method number 1 for part B. It says A is 1 over y square. Just plug it in over here. 1 over y square minus half. I'm just focusing on this, the red part. So therefore, this is A over here. This is A minus half whole square. This comes out to be all this thing over here. And then we have B over here. So B square is this thing square, and that is over here. Got it? So now when I am adding these two, it should equal to 1/4. So if it's equal to 1/4, let me write over here a little bit of LCM. 1 over 1 plus y square square minus this thing. That is 2 into half into this thing with a negative sign. That's over here. And this is 1/4. So let me again color code it over here. This is the A square term, A minus half whole square. This is the second one. This is the third one. Take care of the plus minus. And then the blue term, the B square, is this thing. So now look over here. When I take the LCM of these two, this is minus y square over this thing. So let me just write everything in black color. Okay. So when I take the LCM of these two, so therefore this thing is this, the reddish color thing, that is this minus this, and this is coming out to be this. This bluish color thing is already there. And these two cancel out, and this 1/4 is there. So make sure that you write this 1/4. Make sure you write this y square over 1 plus y square squared. No need of opening up the bracket. And then we are left with 1/4. That is one pragmatic approach. That is method 1 is plug in the equation and it should simplify to 1/4. That is one approach. So now let's look at the other method and then we can go to part C and D. So the other method is over here. This first method was already done. Now we are working for part B. I need more space. Therefore, I'm working over here. First thing is 1 over 1 plus y square. That is your A. And negative y over 1 plus y square. That is your B. So if 1 over 1 plus y square is A, 1 plus y square is 1 over A. Keep that in mind. B is negative y over 1 plus y square. That is negative y over 1 plus A. This I have replaced it over here. So let me just highlight it. So 1 over A, I have replaced it over here. And then it flips and it goes up. In other words, y is negative b over A. Now this thing is done. Now what am I using? I want to prove this thing. I'm not plugging it in. I'll prove that this will become this. So now 1 plus y square is 1 over A. 1 plus y is replaced with b over A. So this y is replaced with b over A. the whole thing square, and then look at the working. So the working is right over here. I can skip this step right now. That is already written. And let me just take this to this side like this. And now let's look at the working. So now the working is 1 plus b square over a square is a, cross multiply by a square. You get this thing, a square minus a plus b square. Now it's almost very close to this. Now here comes in a very unexpected surprise that is totally out of the box. And that concept is that of completed square form. So completed square form to solve a question of complex numbers. So from P1, I'm importing something for P3, and that can happen. So now I have done this. Make sure the coefficient of a square is 1. First add, then subtract square of half the coefficient of x. So therefore, rewrite this thing that is written like this. Take this 1/4 to the other side, and then I have proven it. So this is very, very much, this is out of box. So this is too different of a concept. Of course, most people will find this one simpler, but keep in mind such a different solution is also acceptable. So now coming back to this thing, part C, it says on a single Argand diagram. Let me just double check if the thing is on. Yes. On a single Argand diagram, sketch the loci given by this equation. Which equation is that? That is real part of z is 1, and this thing right over here, where z is a complex number. So when we write any complex number as x plus iy, the real part of z is x. So therefore, x is equals to 1. And when something is given in this form, that is a circle, the center is this thing, the radius is this thing. So now draw the line x is equals to 1. Label the x-axis as real, y-axis as imaginary. The center of the circle, first of all, draw the line x is equals to 1. Center of the circle is half, radius is half. So half on this side, half on this side. Make sure that this is tangent with this thing. That's how this is drawn. Now in part D, they are saying the complex number is such that the real part of z is 1. Real part of z is 1. Use your answer to part B to give a geometrical description of the locus 1 over z. So now the real part is this thing 1, and it is linked with this thing a minus half b, because it's linking with part B. A minus half b plus b square is 1/4. So x minus half whole square, because instead of a I'm writing x, instead of b I'm writing y. That's it. And this is 1 over z. This is for 1 over z. So when this is happening, what are we getting? We are getting a circle with center 1, 0, and the radius is half. That is the geometrical description for 1 mark. So it was kind of a slightly out of the box question in general, but sometimes such things do happen. Skip and move on and come back to it later. That's the easiest approach. Question number 9. Now this is about vectors. So question number 9, this is about vectors. So question 7, 8, and 9, and then we will time ourselves. Now this question, it took a little bit more time than usual. So now over here, the position vector of point A relative to the origin is such and such. The line L passes through A and it's parallel to this vector, and that is OA. So now this OA, that is the position vector of the fixed point. That is 8, -5, and 6. 8, -5, and 6. And it's parallel to this vector 2, 1, 4. That's 2, 1, 4. That's how the equation is written. Now it says the position vector of B relative to the origin is this much. So now B is there. That is -t. That is 4t. That is 3t. Where t is a constant, the line also passes through B. So the line L also passes through B. So this is the line L. It passes through B. So now if it passes through B, that means this thing can be replaced in place of R, because R is position vector of any point on the line. So now we have 3 equations and we have 2 constants. solve for t, solve for lambda, and plug in the third one. So we get lambda equals to -3, t equals to -2. Check in the remaining third equation. Does it satisfy both equation? Yes, it does. That means it should satisfy. That means that proves that point lies on a line because the value of t satisfies all three equations. So if it was asking whether it lies on the line or not, that is the result. Basically, over here, there was no need as such of checking. So this is just some extra stuff that I've done for this particular question. So t is -2, lambda is -3. They were asking the value of t. Now the next one, the line M has this equation. So there is a line M, and M has this equation such and such. So this is 5, -1, 2, and A, -1, and 3. And then it says the acute angle between the directions is this thing, where cosine of theta is 1/√6. Find the possible values of A. So again, a mainstream question in which you use the concept of scalar product. So now over here, first of all, let me focus on the direction vector of M. That is A and -1 and 3. And that is the magnitude of this direction vector. Direction vector of L, that is 2, 1, and 4. So that is 2, 1, and 4. That is the magnitude. Leave the answer in the square root form. So let me just write it in the square root form. Just extend the square root like this. Or let me just erase it properly. So this is square root of 21. And this is square root of this thing, that is a square plus 10. So this is a square plus 10. That is the square root right over here. And then the square root is the blue one. So now we multiply the I with the I, the J with the J, the K with the K. So this is I with the I, and then the J with the J, and then the K with the K. So that is how you do the multiplication. That is dot product. So this is 2A -1 plus 12. And there is a square root over here. There is a square root over here. There is a square root over here. Just take common like this. And then at this point, you can write one more step. That is square both sides. So when we square both sides, this becomes square, and then you have to work it out. When you work it out, you get this quadratic equation, middle term factorization. You get two values, A is -86 and A is -2. So now the time is 12:48. Let me pause for Azan also. And there were few minutes that were wasted because of some technical glitch. So 7, 8, 9, this is 12:58. Let me make it 12:54 on the safe side. So therefore, this is like 20 minutes. For this thing, I'll come back to it later. Let me pause the recording. So now let's analyze the timings. So this is like 20 minutes. So this is for walkthrough, 20 minutes. So therefore, maximum 30 minutes you should take for this thing. So work in 45 minutes max, work in 30 minutes max. And now this is 1:01 p.m. And let's see how much time the other two questions or maybe three questions would take. So now this is question number 10. And this looks like a differential equation question. The question says, let me just double check the recording thing. Yes, it's recording on. And over here, it says a large cylindrical tank is used to store water. The base of a tank is a circle. Of course, it's a cylinder. It has to be a circle of radius 4 meters. At time t minutes, the depth of water in the tank is h. There is a tap at the bottom of the tank. When the tank is open, water flows out. So there is no inflow, there is only flowing out at a rate proportional to the square root of the volume of the water in the tank. show that. Now, first thing first, that is this thing, which is volume of a cylinder. So volume of a cylinder, that is pi r square h, that comes out to be 16 pi h. Therefore, dV by dh is 16 pi. That is the next thing. So this is step number one. Step number two, that is the rate. The rate is negative. So I can even write it like this. Let me just add one more step. This is one way of starting. That is, the negative rate is this much. Or another option, that is dV by dt, that is inflow minus outflow. So that is k root v. That is another way of starting this. So this is one alternative. This is the other alternative. That is the negative flow. That is proportional to volume. Why it is negative? Because it's a decrease. So this negative sign basically means it's a decrease in the height. Got it? So now then we do this thing. Negative dV by dt is k root p, but v is what? V is 16 pi h. That's right over here. So this is k, this is 16 pi h. Square root of 16 is 4. That's root pi root h. So now all this thing over here and something else, I'll convert it into a single constant, because 4 is a constant, root pi is a constant, k is a constant, so we can convert. So therefore, dV by dt is this much. So we have reached this particular stage over here, that is dV by dt is this thing. That is the next thing. So the next thing starts from here. Okay, that is step number 2. And this is step number 1. So let me write over here. This is step number 1. It's a multi-step problem. Yes, it does take time. This is step 2. So first one is about volume and its derivative. Second one is about rate of change of volume. Third step, that is rate of change. So the green step, that is right over here. That is step number 3. That is rate of change of all these things. They are interconnected. That is related rates of change. So now what do? We have h in terms of t, v in terms of h, v in terms of t. Therefore, we have this thing. So therefore, dv by dt, that is right over here, the blue one, dv by dt, that is dv by dh, that is the red one, that into dh by dt. So make dh by dt the subject. What is dv by dt? dv by dt is minus 4 square root pi k root h. Minus 4 square root pi k root h. What is dv by dh? That is 16 pi. So now 1, 2, 3, 4, 5, all these constants, except for the negative sign, let this thing be this. You don't need to simplify or anything. So therefore, dh by dt equals to this. So that is what you are getting at this particular stage. Got it? So now this thing is done. Now let's look at the next part. How many marks are they giving us? I think 4 marks. Okay, that's worth it. So 4 marks are there. Now the next one, at time t is equals to 0, the tap is opened. It is given that h is 4 when t is 0. This is the condition that we will use a bit later, and that is another condition. Solve the differential equation, obtain an expression for t in terms of h. dh by dt is minus lambda root h. dh over root h with a negative sign, I took this negative on that side, is lambda dt. I changed the sides, lambda dt is this much. I took this thing up. And then lambda t is this thing integrated plus c. Simplify it a bit. Plug in the first condition, find the value of c. Once the value of c is found, so there is the c over here. C is this 4 over here. Once this is found, then plug in the other condition. H is 9 over 4, t is 20. Now you find the value of lambda, that is 1 over 20. So this is the value of lambda. This is the value of c. And then simplify it a bit. Last but not the least, what does it say? Hence, find the time taken to empty the tank. That means when h is 0, what is the corresponding value of time? That comes out to be 80. Is there any unit mentioned? I don't think so. Meters as mentioned. And what about the time? At time t minutes. So therefore, if it's minutes, therefore I'll write t minutes. That is the answer for this part. And there was only one question over here. So only question number 10. Then our timing is too perfect. So let me move up over here. So only question 10 was here. There was no 11. 101 we started. We finished at 107. So that is like 6 minutes walk-through time. And that means maximum 15 minutes for you to try it out. So now let's add it all up. So what do we have? We have 45, we have 30, we have 15. That becomes what? 45 and 45. That is 90 minutes. 90 minutes. And what is the length of the paper? 60 plus 50. That is 110 minutes. So if I can explain it comfortably in lesser time, and this is the maximum time that you can comfortably try out, you are in safe hands. So that completes this particular paper, which is October-November 2024, variant 31 from Mathematics with Shahab Yaqub. Take care, everyone.